Thank you all for coming out to the Tulsa.NET user group. Tonight we got Rob Richardson talking on some great .NET testing best practices. And I'm very excited about this. Rob has been a great friend that I met, about 5 or so years ago at a conference and talking over Kubernetes, and we just not stopped talking since. We love talking about tech and all kinds of great stuff, but he's also a fellow co-author with me on a book on microservices. So Rob, I'm so glad you're here. I greatly appreciate it. And like I said, you have hosts, you're sharing your screen right now. I'm gonna go ahead and head out of here. So I will let you take it away. Thank you, Rob.
Sounds great. And I'm glad you're focusing on the things that are important. So let's dig into .NET testing best practices. Thanks for the intro, Sean. Here's the part where I tell you, I am definitely going to post the slides on my site tonight. But in this talk, there are no slides. This is it. The notepad of the things. The code that we're going to look at today, though, is online on GitHub right now. So here's the URL. Let me put that in chat as well. And the cool part is that we've got a start folder and a done folder. And the start folder is where we'll begin, and the done folder is where we end up. So you ought to be able to replicate a lot of what we do. And if you want to continue on, then start where we start and then compare your solution to mine and send me a pull request of all the things I got wrong. So that's online right now. If this URL is a little bit hairy, you can head off to robrich.org, robrich.org, click on presentations, and here's .NET testing best practices. And so you can get to GitHub really easily from there. While we're here on robrich.org, let's click on About Me and learn about some of the things that I've done recently. I'm a developer advocate. Microsoft and Docker have also given me some awards. And I'm also a friend of Redgate. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver the completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp here in Tulsa or wherever you connected from, hit me up on email, Twitter, Mastodon, or find me after the event today. And let's get a Give Camp in your neighborhood too. Some of the other things that I've done, I run a .NET user group in Provo, Utah, and also in Chandler, Arizona. And we're talking about Pro microservices in .NET 6. I got to work with Matt and especially Sean on that book. That was a lot of fun. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comments on the air and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rocks mug. So cool. Let's dig into unit testing. And we're going to start here. Let's pop this open inside of Visual Studio. And we have this application. Now, this is a portion of an application that is an IoT thing that allows us to be able to turn on and off lights based on time of day and based on motion. And so that's really cool. We've got this light actuator. We have this actuate lights method. It takes in a motion detected. We can see if it's a particular time of day and if it's been too long for it to be on, and then we'll turn it off. And so we've got some interesting things going on here. Here's get time period based on the date time so that we know whether it's evening, night, morning. And so our task today is to test this. Now, as part of the implementation, we've got some interfaces that we take in. So this implements iLight actuator. That's kind of interesting. We've got an iMotion sensor that we'll use later on. And we've got this light switcher class that is the implementation of how we turn things on and off. Now, this light switcher is not stateful, so it's going to keep trying to turn it on even if it's on, and that's totally fine. So this is the class that we've been given. I implemented a few things here in this class just to make it work. So I've got this light controller that takes in a motion sensor and a light actuator every second. Then I go ask it, and so I actuate the lights based on detecting the motion. I have an implementation of iLight switcher so that we can we have implementations of turning things on and off. And so then we've got this program that fires it up. Here's our controller that is that implementation of the light controller. And then every second, we go and run the thing. So if we were to start this app, it would successfully do absolutely nothing because, well, you know, it may choose to turn on and off depending on how late it is here, but probably it's just going to not notice motion and just leave it on or off. But that's okay because our implementation is less important than the tests we're about to write. So, yep, it's successfully doing nothing. So let's add some tests. Now, our job is to test this actuate lights method. So let's start out then with adding a test project. Now, I'm going to add a xUnit test project. We could also add MS Test or NUnit or any other testing framework. But xUnit is the one that the ASP.NET team uses. So that's the one that I'm going to use too. So let's say xUnit and find that project. And I'm going to cheat and just grab it out of here because I've used it recently. Next. Now I'm going to add this. Let's call it light controller.tests. And now we've got our test project. What .NET Framework version am I using? I believe I'm in .NET 7, so I'll do .NET 7 here. Let me go double check. It might be .NET 6. Oh, it's .NET 6. Let's make it .NET 7. We'll upgrade it. Woohoo! We just upgraded to .NET 7. Okay, so now we've got our unit test project here. Now I'm going to also add this class. I'm going to add the Fluent Assertions library. Actually, let's do our first unit test first. So here's a hello world test. I'll rename this hello world. Yes, I would like to rename my class. And each test method is just a function that happens to have an attribute on it. Now in MS Test and NUnit, this is called test. In xUnit, for some reason, it's called fact. Sure. Now, when we talk about testing, we talk about time to first it. So let's say int 2 equals int 2 equals 2. And we could say throw new exception, fail. We've got a unit test. Time to first it, no time at all. Now we could choose to assert things. So rather than just throwing exception, let's say assert equal 2 and 2. And now we're starting to get into the details of unit testing, but that is a test. Now I want to run these tests. So I'm going to come in here to the test menu and I'll choose the test explorer and it'll start to gather all of the tests in my solution. So in this case, we have one. I'm going to click run all. And it looks like we're going to quickly build. And now our tests are running. They're building, and now we'll get green. Nope, build succeeded. Okay, now run the test. Run the test. Yeah, we have to go fire up .NET and get everything started. There we go, we've got a green test. Cool. So now we've got a test. Now let's take a look at the arrange, act, assert pattern. So here we just said, hey, I want to go do 2, but let's set it up. Arrange, act, assert. Now here I'm going to say act. I want to say int actual equals x plus y. That's my implementation. I want to assert that assert.equal actual, nope, expected actual. And I could even give it a reason if I wanted to as well. So now I need to define some things. So let's say int x equals 2, int y equals 2, and int expected equals 4. Now we've done that arrange, act, assert pattern. We started out with act, and then we kind of TDD'd our test, which is pretty cool. We set up the scenario, then we set up the assertion, then we set up the condition that would make that happen. And so it's kind of nice to walk through a test that way. Now, in this case, I could say, switch the implementation and the test would still pass. So in this case, this is probably not a great solution. I'm going to say 2 + 3. And now I expect it to be 5, and 2 times 3 is not 5. So now I'm validating that I'm adding. So let's change the name of our test to add 2 and 2. And now we have a much more succinct test. Now, I spent a really long time debugging a test once because I had these backwards. And I kept running the test, and the test said, you got 7 and you should have gotten 5. And so I debugged it and I said, well, I also got 5. And so my test should have passed. And it said, no, you got 7 and you should have gotten 5. And it was because these were backwards. So I'm going to add a new dependency. Let's add a project reference here. Nope, not a project reference. Let's add a NuGet reference. And I'm going to look for Fluent Assertions. Now, Fluent Assertions is a really cool library that makes our test a whole lot more legible, a whole lot more simple to read. And it's because of the way it does the assertion library. So we've got that in place. Let's come back to our code. And now instead of actual and expected, we can say actual dot should equal should be expected. And we can also give it a reason. And that reason will be shown if our test fails. Now it's really clear what expected and actual should be, and it kind of reads like a sentence, making our test even more legible, which is really nice. So I really like Fluent Assertions, and so I'll use Fluent Assertions in this project. Okay, so let's come back to our application code and take a look at the test that we might want to build. I'm going to put my application code on the side here. And so let's create a new class, add a class, and I'm going to say light controller actuate lights tests. I'll make this a class. And that convention split by underscores is actually really helpful so that we can now focus on the content. Here's the class name, here's the method name, and then tests. That helps us really carefully narrow down the details that we need here. I'm going to say using Fluent Assertions, and now let's build out the tests. Cool. So what tests do we want? Well, we have this motion detected, and if motion detected, then last motion time is set. So let's create a test, public void last motion updated, or let's say this, motion detected update last motion. Cool, that works. Now, it would be really easy for us to walk away from this method and then someday we run the test and it goes green. So I'm actually going to focus on clean code here and throw new not implemented exception. Haven't written it yet. And now I make sure that this test will fail until I implement it. Excellent. So motion detected, update last motion. Let's say motion not detected, last motion unchanged. Perfect. Now, one of the things that's interesting, let's take a look here. We have get the time period. If motion detected, we're going to turn on. So let's create a test for that. So motion detected, turn on. Excellent. Now, there's another condition where we turn on. So let's say we turn on the evening. So evening, turn on. Cool. And night, turn on. Now, the implementation there might be exactly the same. So we might want to combine those together. Let's say inline data, and we can say we want to pass in a time of evening, and we want the turn on to be true. So now we can say time turn on, we can say string time period, and bool expected. Did we expect to turn it on? Now we've kind of combined those two into one, which is really cool. Let's put fact at the top here. And now we can say for the evening and the night, we expect to turn on. But if it's, and let's come down here, morning or afternoon, we don't want to turn on. So false here and false here. And now we were able to build one test that tests all of these conditions. Now we haven't written the test yet, so we've got that. But now we've covered the case where we've checked this part, we've checked this part, and if those are true, then we'll turn on. But if either of those are false, then we won't. That's pretty cool. Next up, let's take a look at this. If the last motion time is more than a minute ago, then we should turn off. So let's test that. Motion ago, turn off. And I'll use the same trick here where I'm going to say inline data. I want to say 2 minutes ago, or I'm going to use seconds in this case, 65 seconds ago, yes, you should turn off. And 55 seconds ago, no, you shouldn't turn off. Let's pass in those parameters again. Int seconds ago and bool expected. And so we can take a look at that test. That's excellent. And if it's morning or noon, then we should turn it on. So let's come copy this one again, and we're going to say turn off. And in this case, evening should not turn off. Night should not turn off. Morning should turn off. And afternoon should turn off. Cool. Never trust a test you haven't seen fail. Yes. So now we've gotten all of our conditions. We've got time long enough and the time periods. And so that should get our content going as expected. So now let's start implementing these. Now the first test that I want to implement here is the motion detected update last motion time. So let's arrange, act, assert. And so what we want to do is we want to call into this light controller. So we've got this light switcher. Let's say light switcher dot light switcher light actuator dot actuate lights. Okay. So let's go light actuator dot actuate lights. That light actuator will be iLight. Actually, we can do the actual implementation. Light actuator. Light actuator, we'll set it to null right now, which is a definite error, but that will get us started. So now let's light actuator dot actuate lights. And in this case, we have motion detected. So let's pass that in. And then we want to assert that light actuator dot last motion time is changed. So let's go grab the actual var actual equals that time. And we want to say actual dot should not be original. Now we know it's changed. So now let's set this up. Well, true isn't very descriptive. Let's make that a little bit more descriptive. Bool updated motion detected equals true. We've now documented that a little bit better. And we also need original. So let's say date time original equals, I don't know, new date time. The time is not important, so we'll document that. Actual time unimportant. And now we've kind of played that. So light actuator actually came from a different class, so we could generate it. Nope, let's actually add a project reference here. Add project reference to the light controller class. And now we'll be able to get that using statement in here, and that will work as expected. So let's grab the light controller namespace using light controller, and now the light actuator lights up. Cool. Now there's a couple of things here. We need to say new light actuator, and light actuator is going to, oh, we can't get at last motion time. Yeah, GitHub Copilot is amazing. Could I minimize the solution explorer so that we can see stuff? Yes, I can. Good call. Thanks for that, Eric. So now we need last motion time, but in this case, last motion time is private. And so to be able to do it, we kind of need access to it. Now, iLight actuator doesn't have a last motion time, but I'm going to make this public. And I'm going to very specifically document it as public for testing, not part of interface, because we really don't want to change it. We might even say private get, but then that gets a little hairy. Let's just not make it part of the implementation or the interface. Good suggestion. We could use internals visible too as well, but that also means that we need to sign things, and that gets a little bit hairy. Let's just make it public for now. So now I want to say we've got this light actuator, and we need to set light actuators dot last motion time is the original. And now we should have a test that should be able to validate what we're expecting. Cool. Let's run this test. Run test. And we'll get to see if our test succeeded or failed. Cool. We use internals in situations like this. We are not shipping our code anywhere. I agree. Sometimes it works, and sometimes it's a little hairy. Oh, we got a fail. Let's take a look at our test explorer and understand why that test failed. Motion detected, update last motion. We expected light switcher is not initialized. Light switcher is not initialized. Well, let's come back to this and take a look at our code under test. And well, yeah, we're setting the time, but then we're hitting this light switcher.instance thing. Well, the light switcher is this thing up here that actually implements this interface. Why is that interface nested inside of it? Let's pull that out. And because it's static and we have this kind of helper pattern here with init, it just gets crowded. So I'm actually gonna remove that. Let's not do an instance here. Now we don't need this init method, which is really nice. And we can now just make this an instance class that implements the iLight switcher. Now we've got an implementation. Let's actually implement this interface. Thank you, .NET for go do the thing. Implement interface. There we go. So I'll just say console.writeLine off and console.writeLine on. We had that implementation in our, I don't think we actually implemented those elsewhere, but now that we have a class that actually implements this, then here in our code under test, instead of using lightSwitcher.instance, let's take in a particular instance. So light actuator, let's make this a public constructor, and we'll take in an iLight switcher. Now that we have that light switcher, let's create a private field for this. Create an assigned field, light switcher, create a null check, excellent. Now, if you don't pass a light switcher, we'll fail much earlier, which is really excellent. Now here, instead of saying light switcher.instance, we can say just this dot light switcher, or if you don't like this, then there you go. And now we've been able to refactor our code a little bit to make it more testable. Now, we probably also need to update our production implementation code. So let's go look at that. Here we've got, oh, it's not in that implementation. We now have an actual implementation here, which is nice. So we probably don't even need this one. It's no longer part of that. We've got an implementation here that is excellent. And we may also need to adjust our public static void main, because we no longer need to initialize it. Instead, here in light actuator, we need to pass in a light switcher. So let's create a new light switcher and let's pass in that switcher here. And now we've updated our production code to be able to take in that new interface. Cool. Now that we've got our interface in place, we can now come back to our test and say, well, I don't really care what happens here. We could create a fake thing. Let's say public class fake light switcher that implements iLight switcher. And yeah, we need to implement some interface members, but I don't really care what they're doing. So for this test, that doesn't matter. And now I can say, well, I want to create a fake light switcher. And maybe that's just an iLight switcher now here. And now I'll pass that in here to my light switcher. And now I implemented that interface, which allows me to be able to do the things. Let's run this test. And we'll see that now it goes green. Or I'll go get to debug it again. One succeeded. Test Explorer. Oh, we've got it green. Excellent. That icon is so tiny. I'm not really thrilled at that, but it's like, hey, it's green. Nice. The Test Explorer is actually really helpful, but because so many of our other tests are red because they're not implemented, then that might be a little bit less helpful. Cool. Now we've got this fake light switcher thing, which is interesting, but we had to kind of implement it and we really didn't care. Let's pull in a library here for to help us with these mocks. So I'm going to add a new NuGet reference, and we will look for MOQ or mock-u or mock. But, you know, calling this mock is just a little bit weird. Okay, so we've got mock now in place. I'm going to say using mock. And now I'm going to go delete this. I want mock to go create one of these for me. Okay, so now I can say, hey, I want a mock of light switcher. And go create me a new one of those mock things. Go figure out the things. If I want to implement anything, in this case I don't, then I can, but now I have this mock thing. How do I get at the thing that it created? That's .object. And so now I have a test where I didn't need to make up this light switcher thing. Let's run that test, see if we still got green. And that's excellent. Now we've got a test that is green, and let's go on to the next one. Motion not detected, last motion unchanged. Well, that probably looks a whole lot like this. Let's start out with this implementation, and instead it should be original, and motion detected is false. And now we've implemented it, so we can delete this, and let's run that test. Run test. Now, at this point, I could probably start to create a parameterized test, because you're right, the majority of it was the same, but I kind of like documenting the difference. So we've got this test, and that one went green as well. Motion detected turn on. Cool. So now let's set up this condition. Well, we want to arrange, act, assert, and we had motion detected, which was kind of similar to here. So let's go create our actuate lights. We've got a motion detected, and we know that in this case, we want to set our original date time to something where it will change. So as long as the original is not the current, then that's fine. Let's go grab our setup here again. And now we're detecting motion, and we want to go see if it turned on. Well, this light switcher is the thing that will turn on. So we want to go see if that's turned on. Let's say I want to now set up this object. So light switcher dot setup. I want to say if you call m.turn on, then I want you to do this. Callback. It doesn't do anything, but I'm going to say turn on is, or actual is true. Cool. So I'm going to set up here, bool actual is false. I might even say called, turned on. I could also go ask my mock if it was called, but that is kind of interesting to do as well. So now I'm going to say, did it get detected? And now let's say turned on should be true. Or I'm even going to say expected. And here I'm going to say bool expected turn on equals true. And now I know if that got called. Cool. So my thing is here, and it's setting a particular date, but let's come back to our code and say, well, I've got some motion detected. It's got this time period thing, and I want to make sure that the time period is not one of these two things. So here's this get time period method, and that's kind of based on this time that is now. And so I really don't have a whole lot of control over that. Really, in this case, my test, I only really care about what get time period returns. And right now it's this private method. So let's actually move it into another class, public class, time period resolver. And now that we've got that class, we could even create an interface for this. Go Gadget Visual Studio. And let's extract interface. Visual Studio, you failed me. Public interface, time. Oh, that's because it's private. Let's flip this to be public. And now we've got this in a different method. Let's extract an interface now. Extract interface. I could choose to move it to another file. In this case, I'll just put it in the current file. So here's this interface time period resolver. And so now I can take in this time period resolver, and let's add that as another field, and we'll do a null check. Now I can take this time period resolver, and now I can take a whole lot more control of that in this test. Now, because I separated this out, then my program's going to get a little mad. I also need to put in this time period resolver, and this is getting a little old. I really want an IOC container where I can say, well, let me just go put in all of the things that I care about, and you go figure out what I need to. So let's start here. Let's say var services equals new service collection. Service collection. Service container. No, service collection. And for a service collection, I'm actually going to need a new NuGet package. Let me grab Microsoft Extensions dependency injection, and that will grab that service collection. And now I can say var container equals services.build. And then I can say var controller equals services.get container dot get required service light controller. Cool. So the light controller takes in a thing, and so I'll need here in the services to say services dot add, in this case, I'll say add singleton. And I want to say a light controller implements light controller. Do I have an interface for light controller? I don't think I do. Nope, I don't. So that's fine. I'll just say a light controller implements itself. But I also want to run around to these other services, adding them as dependencies. So a light switcher interface is of type light switcher. That works out well. I've also got this light actuator that is of type light actuator. I've got this motion sensor that is of type motion sensor. And I'm now explaining to my IOC container all of the things that I want to set into that container. So when it comes time to resolve this, it says, well, I need a motion sensor and a light actuator. And to get a motion sensor and a light activator, I also need some of these things. And for the light switch, for the light controller, I need a motion sensor and a light actuator. And so it then goes and resolves all of those dependencies, which is perfect. I could say set up IOC container. And then now that I have my container, then I want to use IOC container to start app. Now, I probably want to use get required service as seldom as possible, because that will go reach into the IOC container and go grab things. And so I probably want to do use that probably only once. Ooh, does xUnit tear down the entire test class between each test, or does it use the same instance over and over again? It actually creates a new instance of the class each time, which is really helpful. Eric, you have a great question, and ask me in a second, because what we notice now is our application will build, but we have dependencies for the light actuator. I now have a second dependency here, and so I could go say time period resolver mock, and now I have to go figure out that, but I really don't want to do that. What we did here that was really helpful is we created an IOC container where we could just fill it with, here's my here's my interface and here's my implementation, and I just want you to go figure it out. Let's do the same thing with our tests. Now I'm going to pull in a program, NuGet package. Let's manage NuGet packages. Oh, that's an interesting place to put it. Let's move it over here. And I want to pull in AutoMock. Now, AutoMock is an IOC container for tests. Perfect. Now I'm using MOQ, and so I'll pull in the MOQ version of AutoMock. And now what I can do is I can say in this test, I need a new light actuator, but I don't really care about the dependencies except for the ones that I do. So let's say AutoMock. We'll say new AutoMocker. We need to pull in that namespace. Thank you. So var mocker equals AutoMocker. We could also say IOC container if that makes more sense. And now this is our test IOC container. Here, instead of saying new, I'm going to say, hey, IOC container, mocker IOC container dot create instance of type light actuator. Now it's going to go figure out the dependencies it needs and then give me an implementation of that. As my dependencies change, I no longer need to change my test. Now, I did make this light switcher mock that I want it to use. So I'm going to say IOC container dot register or dot use this light switcher. So if anyone wants a light switcher, it will happen to use this one that it just built. Now that's cool. I now can run this test, and it actually won't build yet because I haven't fixed my other test yet. But now I don't need to change my test when I change my dependencies. Let's do the same thing over here. So let's go create this, and let's go create our actual implementation. And now I don't even care about this mock. That's not relevant to this test. I don't want it. So now let's just go run this. And now we'll see that our test is a whole lot more legible. Oh, I've got a build failure. Time period resolver. Oh, I have one more test that I need to fix. Okay, so let's set those in place. Cool, now it'll build. Build. Oh, one failed. Which one failed? Oh, yes. Thank you. I'm not sure why that didn't trigger earlier, but in xUnit, when you have parameterized tests like this, you have to change fact to theory. Thank you. Thank you, Rosalind Analyzer there. Cool, so we've got that. Now let's run our tests again. running all of the tests. Now, what's kind of cool here with this test explorer is right now we're running the tests very specifically when we want to get the results. There is an option here that we can choose to say, run tests after build. Now, if your tests are fast, then this can be really helpful because as you build, as you're doing anything else, it will kick off all of the tests. And now we can take a look at their results, which is really helpful. If your tests take a while, you may want to leave this off. Now, there is a thing in Visual Studio called live unit testing, and that is interesting, but that is not this. This is just continuously running your tests. Live unit testing is phenomenally cool, but it is an enterprise-only feature, so I'm not going to use that today. Cool. So this test went green. This test went green. This test went green. Oh, this test did not go green. Run tests. And oh, I'm not quite sure why that didn't go green. Let's take a look. I'm going to set a breakpoint right here, and let's debug this test. So we'll get to run the test the way we expected. Now we've got our mock set up. And I'm just using F10 and F11 the way we would expect. We'll set up that. We'll use that. Now let's go create this instance. Let's set our last update time. And now motion detected. So now we're in our actual implementation code here. So now we've got motion detected is true. We'll set our last time, which is cool. Let's go grab our time period, and our time period is null. So is motion detected? Yes. And is it evening or night? I really want to be able to inject this time period, and I haven't done that yet. Okay, I'm glad I was able to debug the test to figure that out. It looks like I need another mock. Let's now do this. I'm going to say, I want a mock time period resolver. Time resolver equals new mock. I could also go into, I can also get AutoMocker to generate me one, which does some really interesting things. Create, nope. Get mock of type time period resolver. And the cool part is it will both create it and use it. And so now that I've got that mock, it just invented it if it didn't exist. I'm going to say time resolver dot setup. And so if you call the get time period method, I want it to return evening, because it will only turn on if it's evening or night. So it doesn't matter what it is. And to that end, this is not quite as clean as I want it to be. Let's say dark time, string dark time equals evening, not important. Something that'll turn it on. Cool. Now get time period actually takes in a parameter. It takes in a date time. I could pass in this particular time or now. I don't care. I would just want it to say it is any date time. And now my mock is set up to be able to accept a time period that returns whatever. We've kind of defined a fourth section now here, set up mocks, and that helps us kind of designate this as a section. Now, I don't always need that, but this is getting a little bit hairy, so that might help. The other thing that we could do to make this a little bit more legible is we could move some of these mocks into a separate method. So we've got this time period resolver that does some interesting things. What if we took this and said, I would like to extract a method, please. And I'll say setup time period helper. Cool. So it's going to do the thing, go grab the set up the date. I don't care. I just want it to return that time. And now that's a little bit more legible. Let's do a similar thing for this one. Let's extract method and say setup setup turn on. Setup turn on callback. Ooh, that's going to be a little hairy with this callback thing. I think I'm going to undo that and leave it in place. We might come back to that and see if we can find a better way to do that. Cool. So now if I want to debug this, let's set up a breakpoint right here. And let's go debug this. Debug my test. Now I can start to walk through my test and see how these mocks resolve. Ooh, time period resolver.get time period may not be used in setup verification expressions. That's unexpected. Is this not public? It is public. Yeah, I don't like that at all. I think this test may be a fail, or I may need to go look in my notes and see how I did it last time. Let's go cheat. Done. Motion detected. Oh, I'm doing this one. Okay. I returned the thing. Yep, that's as I expect. So that's interesting that my test is failing in that way. Perhaps it's only failing because I've, ooh, I know why it's failing. Time period resolver. Let's come back to this one and take a look at how I implemented time period resolver. And I bet I implemented it slightly differently. Nope. Okay, so I'm going to definitely need to take that one offline to figure out why that test failed. Test Explorer. Motion detected, turn on. Let's take a look at this result and see if we can see it real fast, and then I'll move on. Nope, it's just going to be mad. Actually, what if I do this? New mock. And now I do that, and then I have to say IOC container.use time resolver. Oh, I bet this is why. Because it's an implementation, not an interface. Silly me. IOC container dot get mock. There we go. That will work. I was trying to implement an actual class, not an interface. Silly me. Run test. What did my helper method do in the finished example? It did pretty much the same thing. So let's go pull this application code over here. And I take in a time period and I return a string that is the particular time. Cool. So here's my, did I move that into, I moved one of them. Where's my little method? Oh, I bet I undid my little method too. So let's set up a, this one, extract method, set up time period helper, and I have return time. And so now I've got that. I tend to like putting in my IOC container first, just because it's the first one of all the methods. So I could have used some Visual Studio magic, but I just did that. Now let's refactor this one and say extract method get turned on. And the interesting thing here is that I actually don't want to take it in, I want to return it. So I'll say an action of bool, nope, it's a func of bool that is my callback. And so whenever this happens, it will actually do this. And so now I know that when turn on gets called, it will call my callback. Cool. So I don't need to return anything here, but now I will take in my IOC container, and when it gets called, I will set my turn on to true, and now I know it's done its thing. So I find that a little bit easier as we set this up, because these methods kind of abstract away the implementation, and my test is now really legible. Let's make sure this test still passes. It does. Nope, it doesn't. What did I do? Invalid callback. This overload of the callback method only accepts void subdelegates with parameters. So I've got this callback that expects something else. Oh, that's why, because it's an action, not a func of t. Okay, that makes sense. Running this one more time. Run test. Now it'll go green. I didn't take in a bool here. I just wanted to know if it got called. My test explorer is now going to tell me that that test is green. Perfect. Okay. So now these methods may be helpful to move to the bottom. We might be able to use them in other tests. Let's implement this one. So is it time to turn on? So let's come grab this content here, and we'll set that in place here. And now motion detected is true. That's not really necessary for my thing, but I do need my motion detected to be true so that I can get into the right time period. So I'll just say that that's true. Testing time and motion detected. So perhaps it's even better to say const bool. Cool. So now bool actual turned on. That might be a little bit more descriptive here. Expected turned on there, and the time period is the time period that I want to put in here. Did I spell expected? Oh, yes. So now that I've got this parameterized test, I don't need that anymore. The original is not necessary. It's just something that is not today, not now, so that it will change. So I'm going to set that in place here. That makes this test a little bit more legible. I'm documenting then which values I care about here and which ones are not important here. Cool. So now we've tested all 4 of these conditions. Let's run this test and see if those work. Good call. Shouldn't it be an action, not a func? You are completely right. Thanks for finding that, Eric. I should have looked more closely. Cool. So now we were able to test the turn on method for evening, night, morning, and afternoon. Cool. All in one shot. We don't need 4 different tests that test pretty much the same thing. We just need one test that tests all of them. Okay, so let's test the turn off in the same way. Now we need it to be dark. So let's say expected turn on here, and the time period is what we pass in here, but we need it to be dark now. So let's say motion detected is false. And so now that we've got that in place, we should be able to test this. Let's run all of these tests. Oh, we're actually testing turn on. We don't want to say get turned on. We want get turned off. And so let's refactor that a little bit. Expected turn off, actual turned off. And now in this method, we are going to set up the same mock as we had before. So let's go get that method here. I'm going to move it to the bottom just so that we can focus on our actual test. We get turned on, and we need a get turned off method. Now, yeah, we could pass in a bunch of flags saying, but this one's, do I want to rig turn on? Do I want to rig turn off? In this case, I really want them to be separate methods. So I don't need to rig the methods that I don't care about. I only want to rig the methods that I do care about. Cool. So now that I've got that expected turn off, let's run that test again. Run test. And I never mix those up, never. Now let's test to see if we've got turn off functioning as expected. So our build succeeded. Let's come into our test explorer and time turn off. We've got some green and we've got some red. Evening expected turn off to false and night expected turn off to false. So let's see if we didn't turn these off correctly. I'm going to set a breakpoint right here, and let's test evening. So I'm going to comment these out temporarily. Now, it would be really easy for me to accidentally commit the code right here. So I'm going to give myself a note. Don't commit this. I might even go a step farther and say, throw new not implemented exception, turn test cases back on, so that I don't accidentally commit it with those test cases off. But I just want to test this one test case, so I'll do that. The other way is, I just push go on each one. So let's run tests. And now that we've got our test kicked off, let's see where we're going to go. Now we're rigging the turned off, and we're setting the time period helper to that evening time period. Excellent. Build started. Debugger. I bet I clicked run test instead of debug test. Here we go. Okay, so did I get the time period that I expected, and did I get the turn off as I expected? In the evening, do I want it to turn off? Well, yes. Oh, I need that. Visual Studio may make me restart my, yep, it's going to make me restart my test because I changed the spelling. Let me try that again. Run debug tests. Should it turn off in the evening? Oh, yeah, it should not turn off if there's no time. So let's dig in here. Was motion detected? No, so last motion time did not change. Did we turn on? No, we didn't. So is last motion time greater than the number of minutes? In this case, we did turn off, so we'll set actual turn off to true. And so really what we're testing is the time long enough? So it sounds like we really want the last motion time to be longer. So that actually, nope, I got that wrong. It has been long enough, and no motion has been detected in that long. So we should turn off if it is morning or noon. And in this case, oh, it has been long enough. And so we're actually testing the wrong condition. So here in our test, we said, I want this to be not now. In this case, we actually do want it to be now. Because not more than a few minutes ago. Whoops, we forgot that condition in our test. Let's now uncomment these and remove our exception, and let's test all of the conditions and see if we've now got our tests to pass. Good call. I love that idea, Eric. Write a Visual Studio extension that blocks commits if there's a marker somewhere in the code like exclamation points. Completely agree. So our test explorer says we got 3 greens and 1 red. Afternoon. Let's take a look at afternoon and see if we can do that. I'm going to go the other way instead of commenting them out. In this case, I'm going to say debug tests. And what is my time period? I'm going to pin this one so that I can take a look at it. I'm after afternoon, and that's not it. So let's just go. Now I'm at afternoon. Excellent. So let's go in here and we'll take a look at here. And if it's morning or noon, ooh, noon. Noon is not afternoon. I think we have a constant that is an error. I'm glad we had these tests to help us get a better experience through our code. It looks like these magic strings are not helping us. Let's create an enum here that gives us the various times. So public enum time period. I'm going to say night, morning, afternoon, and evening. Those are the 4 times that I've defined here. And so now instead of returning a string, I'll return a time period. Let's do that. I'm glad this test helped us find this code that wasn't behaving. And so now we can make our code a little bit cleaner. Now, the cool part is that this is just more or less an implementation detail inside of our internal things. So now we don't need to do a whole lot of mayhem of refactoring. So that returns a time period. We're now going to test that time period in all of the places. We could also maybe create constants that we reference here, but an enum in this case is probably a better choice. So is that afternoon, not noon? Cool. Now there are a few places in our code that we need to change as well, because we pass in, oh, I forgot one. There's a few places in our test that we need to change because we were mocking this time period resolver class. And so now in our mocks, we need to pass in a time period, not a return time. Okay, so in all the places where we did that, which was right here and this takes in now an enum, not the magic string. We'll need to update those places. So yeah, we are changing a few tests, even these tests that were green before, but I would argue this is a good place to make that code a little bit cleaner. So we've got then, nope, I don't want to open that. We've got, oh yeah, click the wrong icon. We've got now this code set up to take in a time period. Did we fix all of the spots that were strings? Let's run our build. That succeeded. Let's run our test. Oh, one last spot. Build. Okay, now we've got all green code. Excellent. Let's fire up our tests. Run all the tests, please. Yep, we haven't written that test yet. But all the other tests that we have are green. Excellent. So let's take a look at that last test that we want to implement. If it has been long enough, then we should turn off. And if it hasn't been long enough, then we shouldn't. So we've got this same turn off scenario, which is excellent. In this case, we need a light time period. So let's say time period, a light time period equals time period dot morning, something in the day. Now we've got that in place. Expected turn off is there. And seconds ago, we need to pass in something that will set last motion time the way we expect. So here we're seeing if time is greater than last motion time. So time by default is right now. We could create an abstraction to get away from right now, datetime.now, and that might be a good way to go here. But I'm just going to say we just need to get within so many minutes. So let's just set our last motion time and not detect motion. Should we detect motion? Motion detected is false. And so now we need our time to be datetime.now.subtract time time span from seconds. And we want to say seconds ago. And now that was actually one of our big concerns, one of our start things. So let's move that. Last motion time, it's integral to our test. So now let's say date time, last motion time equals that. And a comment might help us. So testing, if it's been long enough to turn off. So that's probably the critical piece there. So that may make more sense. Cool. So let's run this test. If it's 65 seconds, we should turn off. If it's 55 seconds, we should not. Let's run these tests. And now we go green. Run all the tests. And we are all the way green. No, we're not all the way green. Did I get them wrong? Let's debug that test. Did both of them go wrong? Nope, just that one. Okay. So I'm going to debug this test. Debug tests. Is this the 65-second one or the 55-second one? It is the 65-second one, so that one's fine. Let's come back to the 55-second one. And now, motion was not detected, so I didn't change last motion time. Last motion time is 52:34, and time is 53:36. So, or time period is morning. Uh-oh, I passed in the wrong time period. That's why these tests are passing. So I loved your point early on, Eric. Something in the night. I don't trust a test until I've seen it go red once, and I cheated a little bit here, and that's why I got burned. Making a test go red and then making it go green can be really helpful, or we can do property-based testing or fuzz testing where we can start to modify our code and make sure that our tests succeed or fail. So it looks like we're completely green now. Let's double check. Now, where could we go farther with this? Well, we've been able to test all of these conditions in our application, but what we noticed was when we were testing this piece, we need to mock out this piece. And when we're testing this piece, then we kind of had to fake this piece to be able to get our time period to work as expected. It might make sense for us to move this and this into separate methods that actuate light calls. Now we have a test suite that allows us to be able to refactor mercilessly. And so we could move those into private methods, validate that our tests all still pass, maybe have a few smoke tests to validate that, and then move these unit tests to test the particular methods. Now, the cool part about that is that because we've chosen to use AutoMocker here, and it just automatically passes in the dependencies that we need, then we really don't have to change that. The only thing we need to change is the method that we're calling. To that end, our tests might get simpler should we refactor our code into interesting ways. Now, I'm not going to do that today, but that could be a really cool way to be able to explore this. We also spent a lot of time trying to fake this one so that we could test this one. And so maybe moving those into separate methods might be interesting to be able to further experience this. So Eric, you had a great question. What are your thoughts on loops in tests? Where could you test test hundreds of cases where there should be a mathematical pattern, like calling the period helper implementation once per hour and making sure there aren't any exceptions? Writing 24 inlines would be tedious. I completely agree. And to that end, we could create a loop to test this. You know, let's go test it once for every hour. Property-based testing is really interesting, where it can go figure out where the bounds are. But we might actually set up something like this. Let's go build that test, because that'll be fun. That's going to test a different class. So let's create a new test class here. Add new item. And I'm going to say, oh, what was the name of the code? time period resolver. Add time period resolver, get time period tests. And let's explore exactly this concern because I love it. We could say public void test evening, and we could say var expected is time period dot evening, and var in equals date new date time hour, and then var hour equals 20. And yeah, now it's like, well, the only thing that I'm varying is these two. So we might try to do that. This is actually moving to a theory though. Inline data, we could say hour is 18 and expected time period dot evening. And so yeah, now we're starting to duplicate all of these conditions for 19, 20. That gets tedious. What we could do instead though is we could say member data and name of some property, public list object, some property, and get return. Now I can iterate through all of those conditions here, and it will do that the way we expect. So now I'm going to say, maybe I have unfortunately, it must be an object array and a list of object array, which I find to be really annoying. So I'll usually create two properties, one that is an object array and one that is not. So this will be hour is 20 and time period dot evening. And now I'm listing my 20 conditions here. We moved in the right direction here. And that one is this. I have to do some casting magic to make that work, but I'll ignore that for now. And so that's really interesting. That kind of gets us more towards this thing, but we could also do something like this. For int I equals 0, I is less than 24, I plus plus, and build them that way. And that kind of speaks to your loop. I don't like doing a loop inside here, but doing a loop inside this property is actually really interesting. Even more interesting is this database query.execute, select star from my orders, where some condition. And now I can replay the last, I don't know, 10 orders, 50 orders. And that makes it really helpful because I'm like, if we're not getting the same answer as we did when we did this last time, then we kind of need to change our logic. This is a great integration test. And so I'm going to comment this out because otherwise this won't compile at all. But that's where I would go in this case. If you wanted to take it a step farther, then property-based testing is a really elegant methodology. So I can say property-based testing, and what was the library that I was learning about? It wasn't Codeit, but Codeit looks like it's going to do it as well. The cool thing, oh, FS check was the one that I was after. Go away. So the cool thing about property-based testing is you just say, I've got this condition and I want to be able to validate that condition works as expected. That was a wonderful question. So we talked about how we might take this further by refactoring our code, but let's also take this farther by running our tests continuously. So we were running them inside of Visual Studio, but we could just as easily, here's the two test projects. We can say .NET build, and we probably do this in our CI/CD platform, but we can also say .NET test. And when we say .NET test, it will actually go run all of our unit tests in the solution. And if they succeed, then we'll get our test results. And if they fail, then we'll get a non-zero status code, which then we can do interesting things with, like fail the build. Now, in this case, it just said, oh, they all pass. That's pretty cool. But we might want to take this a step further to be able to harvest the test results. Which one failed? How long did it take? And so let's come back in here and we'll manage our NuGet packages, and we'll add one more package. Now I'm going to add xUnit xml.test_logger. And this will actually output our test results in JUnit format. Now, JUnit just happens to be a standard format. It was created in the Java community and thus the J, but it's just an XML format. And so it's just, it allows us to do some stuff. So now I'll say .NET test, and I'll pass in a logger, and I'll say JUnit, oops, and log file path is up one directory into the results directory, and then test result.xml. Cool. So now when I run my test, not only will it output the test results to the screen here, but it will also JUnit. Did I pick the wrong unit test, or did it? Oh, it didn't rebuild yet. That's why. Test logger. Yeah, now that it rebuilt, in my CI/CD platform, I would do a .NET build first, and yeah, oops. Now that I've got that JUnit test result, now we can come back into the folder. And we can see this results folder that has that XML file. So let's just pop open that XML file just to take a look at it. It's, quite uneventful. It just says, here's the test, and it took this long, and it succeeded. Here's the succeeded and failure things. So now we've got that test results file. Let's wrap this in a build process. So I'm going to come here into the done folder, just because, save us a smidge of time in building the test. And I'm going to take a look at GitHub Actions. So I came in here to GitHub Actions, and I created a new action run, and it created this file right here. Now, what I said in this build was on branches main, on any pull requests, I'm going to run this process. So what am I going to do? I'm going to go into the done folder. I'll .NET restore, .NET build, run that .NET test process. I probably also need to .NET publish and start my app, but then I will run my test report. I'm going to specifically do this if always, and I choose to do this. I love your test failed PowerShell prompt. Yes, that's awesome. I'm going to specifically do this if always, because I don't want a failing test to not publish the results. But I'll go look in that results folder, and here's my reporter. And because I've chosen to publish these results, when I kick off a new build, I'll be able to see these results. And so not only do I have the build together with all of the build steps, but I also now have this new test results tab because I chose to publish those test results. And here's all of my test results. Here's all the tests, how long each one took, the fact that they all succeeded. And so now I have a great test dashboard associated with these test results. I pulled in the xUnit test reporter just because that's what my dashboard chose to use, but I could also pull in a different reporter if I wanted to grab the tests and say MS build format or xUnit format. But xUnit is pretty standard across the thing. So if I publish my test results as xUnit format, together with my test results from my React app or my Vue app, then now I can correlate those into one dashboard that will do them all, which is really helpful. So that was really cool. We started out with an application that was kind of, well, awkward. Our application code had some static stuff that made it difficult to mock. We also had some magic strings that, by the way, were wrong. And we were able to build up a suite of tests that allowed us to be able to validate our application behaved correctly and allowed us to discover some bugs along the way, which was really helpful. We've now got this suite of tests that happen to use AutoMocker so that we don't need to modify our tests if we add additional parameters. And we cleaned up our code a little bit along the way too. We used parameterized tests to avoid duplicating tests, which was really helpful. And now the entire suite of tests is here in this done folder up on this repository. The repository is on GitHub right now. And so if you're watching this on demand, hit up that repository, github.com/robrich/nettesting xUnit MOQ. And if it's easier to get there, head to robrich.org and grab the solution straight from there. If you're watching this on demand and you have thoughts or questions, hit me up on Twitter or Mastodon, and let's continue the conversation. But for those of us here in the event, what are your thoughts? What are your questions? How can we extend these tests further? Kids. I can.
Yeah, I got a question about like organization. Like you know, back in the old days, before we created separate projects, we would, you know, you would do the .test, you know, so that you're, you know, you had a class, you know, foobar, and you had foobar.test, you know, and they would be right there, so that when you were going and working on the unit tests, it was easy to like know that the unit test for this particular class was, you know, whatever the class name is .test. And now with I've noticed that now, you know, the standard is to, you know, to create a test, you know, completely separate. You know, you've got source and then you got tests, and inside of there you got a bunch of projects. And there seems to be like, I don't see like there doesn't seem to be any kind of like standard on like how to organize that so you can actually find the tests for a particular class. I mean, I noticed that you're doing you're putting, looks like the class name underscore method name.
Yep, that's how I do it, is class name underscore method name to be able to discover it. But you're right, they are in different projects. I tend to mirror my folders in my tests to match the folders in my original project, and that helps. I also tend to name my test project the original project .tests, and that helps me discover them as well. But I agree, they are kind of in separate places, and it's like, well, but how do I do that? One of the ways that I will kind of correlate them as I'm building the test is I'll put them side by side. And we saw how that didn't quite work in this case because my font size is big. But that's another way to kind of try to correlate them. But yeah, at the end of the day, you're kind of fishing through different folders to get at different things. Yeah, sorry. One could make the same argument about controllers and views though, because controllers go in this folder and views go in that folder. And it's like, how do I Yeah, I agree. That's not a problem solved very well. One of the reasons that we did choose to separate this, though, is that our test project has a whole lot more dependencies specific to our unit tests. And so I probably don't want to deploy my code with references to these test dependencies. And that's why separating that into a different project may be a little bit easier to consume because, well, yeah, my production code is not affected by my test code.
Yeah,
That's a really great question, though.
Yeah, I like the separate project. I didn't know if you'd come across any good naming conventions on like how to like, although that I've never tried that where you've got the class underscore method. That could be something we could try.
Yeah. The C# purists are like, don't use underscores. And I'm like, but you know exactly what it is. And if I mashed all these together, it would be harder to read. So yeah, I think the underscores really helps there.
Yeah.
Together with naming the methods, sometimes we'll name them the condition dot the result, or you might want to name it in similar ways to be able to very clearly define what you're after. What convention do you like, Robert?
I mean, like I said, in the old days, you know, we would have the same class name dot test. And then what I've done, like, you know, in core is try to just mirror what I have in the actual project. I'm on a project now where there's just a huge there's a horde of existing tests out there, and they are just they're all over the place. So you know, we're trying to clean up, and I'm like, good grief, these are just there. It's like you could tell every time there was a new team that they sort of ran a different direction. So
yeah. And the hard part is then corralling the lava flows. There was a really cool article about, you know, and the new team starts out a new thing and they have a new technology and it flows over. And then we have a new team and so we have all of these competing lava flows. Yeah, that's a hard problem to solve.
what about extracting time? Like another thing we're kind of facing is we're not really testing. We've got workflows and timeouts. And one thing that I've seen, and I haven't done it yet, is where you basically wrap time so that in your unit tests you can actually you can change your time so that you can force timeouts. Have you ever done that before?
I have, and the cool thing is right now we've got this hard-coded datetime.now, but in the same way that we extracted this, we might create, I don't know, public time helper. Probably not a great name. Public date time get now. And if this implemented an interface, oh, yep. Thank you, VS Code, or thank you, GitHub Copilot. Go implement there we go. And now it's going to tell me, oh, by the way, you can use an expression body method. Yeah. But now if I extract the interface into the current file, I now have this interface that will return now that I can mock in a whole lot easier way. And so, yeah, being able to mock time is really helpful. To that end, if you're trying to force timeouts, are you testing your code? Or are you testing the library? It may make more sense to move this to an integration test where I actually point it at a data store that doesn't exist and set my connection string timeout to something small and validate that that works as expected. But now I'm kind of testing .NET. Does it add value to me to test .NET? Probably it makes more sense for me to test my code. So maybe I have a thin wrapper around data access, a repository, and now I can mock my repository in most of my tests, and then I can test my workflow, I can test my conditions, but I don't need to depend on those expensive external resources.
Yeah, well, what we're finding is that where we're having bugs is the, when a timeout happens, you're supposed to do this to remediate that. And we're finding we've got bugs in that, and those are never getting tested because most of the unit tests are all happy path. So we're trying to figure out a way to sort of force the unhappy path to make sure that we're not crashing out when we try to like recover from a timeout or an exception.
Right.
Yeah.
And that's why when we first began, we started out by looking through this method and kind of saying, what are all the conditions? And so then we just listed out all of those conditions as tests and then started to implement them. If we're only testing the happy path, we only know the happy path works.
Yeah.
Now the correlation here is, well, why don't I harvest code coverage? And yeah, code coverage is something that's easy to measure, but not super valuable because it only tells me if a particular line of code happened to be involved in a test. It doesn't tell me if I've tested all of the paths through my application. That's more about scenario testing. And if you have a thin code, I've lost the word, complexity, then you don't have a whole lot of nested conditions, and therefore you may only have 1 or 2 or 3 paths through it. Like we have a path that is here, we also have a path that is here but not here, we have a path that's here but not here, and so we have really high cyclomatic complexity in this function. Mm-hmm. So just validating that a particular test hit every code path is not really validating that our system behaves as expected. So I like to start off just kind of analyzing the method and just enumerating all of the different scenarios that can happen through that code, and then go implement all those tests to make sure that I've covered all those things. I agree, testing the happy path is going to be the most crucial. So I'm not going to fault the team for focusing there first, but the fact that they only focus there, I agree, is somewhat suspect.
Yeah, typically like to test edge, where you do happy path, but then kind of go over the edge a little bit to make sure that you're actually breaking. Yeah,
Eric makes a really good point. No coverage will show you that you have bad testing. Good code coverage does not prove that you have good testing. And I would even take that further, Eric. If you have 100% code coverage, you spend a lot of time gaming your tests.
Is there a good tool for code coverage that doesn't include JetBrains or Enterprise Edition?
There was a tool that, let me see if I can find it in 28 seconds. I want to say it was .NET Cover. Code Magazine. .NET Cover was free for the, .cover was free for the longest time. It is no longer. And so now there's a whole lot of workalikes that are similar. So .cover being the one that we all reach for. The fact that it's no longer free means that we go reaching elsewhere.
Yeah, I can't get my company to buy the suite from JetBrains. So
yeah,
I feel like I'm flying.
And it was free, and it was like. But to that end, every time I get asked for, hey, can you reach for a code coverage tool? I'm like, what are you doing? Because then they're like, can we ratchet it up every sprint? Can we do from 30 to 40, 40 to 50, 50 to 60, 60 to 70? Can we make it part of our quarterly goals to get to 100? And I'm like, can we not?
Yeah, that's pretty common. I'm at company 3 where we're doing that.
Yeah. Eric, you had a nice comment about HTTP client. I think we missed it at the time, though. Do you want to come off mute and talk more about it?
Yeah, sure. It was basically a library for payment system integration. And it was a pretty good idea to make sure that the requests that I were sending out were actually, correct. So I mocked out the HTTP client by wrapping it inside of another class, since you can't inherit and can't, there's no interface for HTTP client.
Right.
And it's also sealed. So I had to wrap it inside something else so I could test that. And it worked. It wasn't pretty, but it worked. And I had an internal and internal visible too, that would take this wrapper in, so I could mock the wrapper. And then the normal implementation, the publicly visible one, just took an HTTP client in and then put that inside of a wrapper that it created in the normal constructor. Does that make sense?
Yeah. Yeah, that's brilliant.
So were you
I did a similar thing for Link once.
Yeah, were you testing the payloads or were you testing the responses?
I was testing the payloads. Both ways. I mean, I was creating a faked HTTP request. So I tested that the data that I sent from specific inputs to this were correct. And then I also sent back, from the same mock, different responses in to make sure that it handled them correctly as well.
Nice. Yeah.
Yeah.
So by doing that, I could test both ends of the process.
The other way I've gone there is to change the destination URL, override the app settings as my test fire up, and then point it at a fake service that I'm using in the middle of my test that just happens to capture those requests, those live requests, and funnel that back into the test in an interesting way.
Yeah. I think a good way in NetCore now, I mean, this was an old framework project. I think you can add a custom something to HTTP context factory or HTTP client factory. I'm not entirely sure. I haven't tested it. But I think that's a part of the reason why injecting a factory instead of injecting an HTTP client directly is a really good idea.
Yeah, because then you can add filters in there, and in the middle of your test, your filter can just pull out the details on the way through.
Exactly.
Yeah.
That's my understanding, at least. I haven't looked into the details on it. I haven't had to test HTTP client calls in that way. And I mean, this was integration and what's the name? Next level unit integration and
end-to-end tests.
Yeah, this was, the higher level ones. Testing this for unit testing doesn't make sense. Yeah, acceptance tests. Yeah.
Right.
Yeah. Because if you're testing, all the way from outside calls into this and all the way down to what are we telling this server, then I'd say we're more on the integration level.
Right.
Yeah. So just another comment on that. Code coverage. I use CodeRush or find code coverage, but depending on how I want to see the results. Both of them work quite well, and both of them are free.
Oh, very nice. Even better.
Yeah. CodeRush used to be paid, but I think it went free last year.
That's funny. Independ went this way and CodeRush went that way, and it's like, oh, okay.
Yeah. CodeRush is from, is it DevExpress, I think?
Yeah.
So they decided to, just offer it, have it as a pure marketing thing.
That's excellent.
Oh, and regarding your code, by the way, if you want to change it in your examples or not, I mean, it's just a comment. I like to have all expected paths be checked and then have a throw in case of a unexpected result. So, for example, if you take a look at your implementation of the time period helper thingy on that return the enums.
Yes.
Yeah.
Here
you're returning evening.
I would say this should be else. and else, and this else if.
Exactly. Because then you'll catch if, you know, if you missed an equal sign and just did a bigger than or something. Because as you loop through it, you'd catch the exception. Make sense?
Right.
Yeah, exactly. That's just how I would do it.
Yeah, I agree. Now, in this case, date time can only have hours in certain ranges. And so
Yeah,
you
but
can't
if
exactly
you
get
missed,
hour
for example, the
25.
hour and set that to, if you have the else if on line in 9, and you forgot the equal sign, so you're checking if it's larger than 12 instead of larger or equal sign.
Yes.
That would mean
Good
that
call.
12
Then you
would
would hit
return
here.
evening. But with this, you'll catch
call.
that. Oh, crap.
Yeah,
So,
I like that.
Yeah. Just a general recommendation.
Yeah. Making code cleaner is always a good idea.
Yep. Anyways, it is currently 03:28 here, so I think I'm going to jump out. But I've been here for 2.5-ish hours, and it's been worth the time. So thank you very much for this presentation. It was really good.
Most definitely. I've had a blast presenting, and thanks everyone for coming.
Yeah.
Take care. Night.
Mhm.